do we need to really help that process along? And so having this opportunity once again to talk about the maple syrup production, which I find really fascinating, is such a pleasure. I'm glad that you're here this evening. I pulled this picture out yesterday morning for the title slide, and it comes courtesy of the Ohio History Connection. And funny enough, yesterday afternoon, after I put this in the presentation, the Ohio History Connection used it for their social media a social media post during the afternoon. So I thought that was sort of a sign that I was on the right track here. So let's go ahead and get started. Feel free to use the chat function whenever I pose these questions or things that come up. And, I like interaction. I know in a webinar style, we don't have a lot of that. And certainly because of, large audiences, it's difficult. But don't be shy about putting things in the chat because, again, weather is such a personal experience. We experience weather through our own eyes and our own senses, as you'll see in a moment. And so I just want to ask you right off the bat, in your lifetime, pretty simple question: have weather patterns changed? And feel free to put stuff in the chat there, whether it has or hasn't, or what you've seen in terms of the types of changes perhaps that you've seen wherever you live, here in Ohio, Midwest, Northeast, or wherever you're coming from today. So again, we experience weather with our senses, right? We experience weather. This is a picture a little bit outside of maple syrup here, but we're talking about a cornfield out in Auglaize County, west central Ohio, sometime last summer. And we can look at a picture like this and we can feel what it feels like, right? That's because we sense that the corn is probably about chest high, right? We know that it's warm, probably early July for this region. Humidity's getting up there. We're starting to see little puffs of cumulus clouds in the sky. We can feel that. And so we experience weather really all together here with our bodies and our senses. Now, as meteorologists, again, because we want to forecast short-term changes, we take all that information, we put it on weather maps, we show the data and how it's moving across the surface of the earth. And to make those short-term weather forecasts for what might happen 3, 5 days, even 10 days from now. Over a long period of time, we're gathering a lot of data. In the United States, we have robust observations back to the mid to late 1800s here across the United States and Ohio. Some of our oldest records go back to the 1870s. For the globe, generally, we have robust observations back to about 1880. And we've been collecting a lot of information, a ton of information. But what I think is really important and something that I really value being an extension, not just a researcher at the university, but being able to engage the community through extension, is how do we use that data? How do we interpret the data to make useful information? How do we interpret that data to help us make decisions about things like water use, droughts in our row crops, and even, as we'll talk about today, when are we going to see some cold air to reset things across the state after such a tremendously warm December? So again, using that chat, go ahead and answer this question a little bit. I always like to start out with a little bit of context of, what are the conditions that we've experienced recently, and can we put those in a broader context? So was 2021, the year we just finished here, warmer or cooler than average for you, right? And you can specify geographically where you are if you'd like. And was it drier or wetter than average? And I'll give everyone a second to kind of chime in there on the chat if you like. So we see warmer and drier in Worcester, warmer and wetter for sure. Down in Cincinnati, 80-degree days in October. Absolutely. So drier in Worcester, wetter in Cincinnati. I think that's a great observation. Spot on, by the way, between you, Susan, and Lori. Warmer and wetter in central Wisconsin. Warmer March, drier March, wetter summer. So yeah, you're getting into seasonal details, which are really great. Wetter in Northeast Ohio. Drier in Akron, right? So even Northeast Ohio, what does that mean? And looking at, okay, some person said drier in Akron, others said wetter in Northeast. So as you can see, it's a very personal experience, but what did we experience from a climate standpoint? So I'm kind of focused in here on the upper United States, the Midwest, Ohio Valley, and the Northeast. And if we look at our January through December temperatures for 2021, the calendar year of 2021, this is what the average was. I show it's the departure, the difference compared to average. Now, right now, the National Weather Service uses a new 30-year window. It's always a 30-year window. They've been doing that since 1930s to talk about today's average high or average low. Right now, we've just updated from our previous 30-year record to the new 1991 to 2020 normal period. And that's going to play into what I show you in a little bit. But you can see much of the northern tier of the United States was warmer than average for the year. A little bit closer to average in pockets of a few counties in Ohio, for instance, and then across maybe southern Missouri, southern Illinois, and Kentucky. But the rest of us here across the north central and northeast were warmer than average, especially across parts of Minnesota. As a matter of fact, here locally in our region, Ohio had its 5th warmest year on record. Pennsylvania was the 4th warmest, and West Virginia was 10th warmest. And these are records that extend back to 1895. On the right-hand side, you can see the accumulated precipitation, again, percent of normal. Reds indicate wetter than average, dry is drier than average. And it matters spatially and geographically where you live. If you're in Madison, Wisconsin, for instance, very dry, but just to the north and to the south across central Illinois, it was wetter than average, extending all across Indiana, southern Michigan, and western Ohio. But eastern Ohio, parts of Summit, Portage, Wayne counties, extending down into West Virginia in particular, was very dry this year, 34th driest on record. It was fairly moist, right? So Ohio and Pennsylvania, top 30 wettest, West Virginia, 34th driest. So you get big differences over short periods of time or short distances as well. And I apologize I see a few folks might be from a little farther south here. But as you pointed out, they're unseasonably warm across parts of North Carolina. What about seasonally? These seasonal differences and seasonal temperatures do matter. So we talk about our meteorological winter is December through February. If we go back to last December through our February period, our northern states across this region were warmer than average. Southern states, Iowa, Illinois, over to parts of Southwest Ohio and South, actually had a cooler than average winter. Driven strongly by the February cold, not so much December and January, when we had some warm conditions, but very cold February, as you'll see in a moment. Once we got into spring, summer, and fall, the other 3 images that you see, pretty consistent pattern throughout much of the rest of the year, average to slightly above average, really, for those seasons across the northern tier, a little bit closer to average across the southern portions of the Midwest and Mid-Atlantic. So fairly consistent conditions. And of course, these seasonal temperatures can also be brought down to scale a little bit more as well. And so I like to do this exercise where I'm just picking out a city. You know, I'm certainly, for my friend Les picking out, a station in Geauga County here, Chardon. And this is what we actually experience as weather. All right. So the daytime highs and the daytime lows for every day of last year is in the gray bar. Okay. So that was the high and the low. The record high for the date is what you see in the, I'm wondering if I can, laser pointer. There we go. Yeah. So this is the record high. Here's the record lows for the date. And there's a few things to point out. Okay. First of all, we had that glancing blow last February of our polar vortex event. But conditions then warmed up quite a bit, especially in March, and cut the season off fairly quickly there once we got into March with 70-degree weather. Then we had late season cool period, which certainly hindered some of our row crops across, particularly here in Ohio. Late summer through fall here in Ohio and in this site, very warm overnight lows. As you can see, a lot of green space there as well. And then we had this very warm late fall, November, early December as well. So very warm conditions in this part of the year. The other thing we can do is look at precip. Now, I'm going to talk a little bit about precip today as well. This is the daily rainfall for this particular site. And what I want to draw attention to is something that we're seeing across the Northeast and Midwest for sure. We had 9 events at this site between 1 inch and 1.5 inches, and 1 event over 1.5 inches. Okay, so 10 days, 28% of all the year's rainfall fell, precipitation fell in just 10 days at this particular site, a little over 46 inches total in liquid precipitation. So this is something else that's going to come up when we talk about these longer term changes for our precipitation. So spatially, just to look at it a little bit, and being in Ohio, I've got an Ohio graph here, but looking at the state rankings for February, it was the 27th coldest February on record for Ohio. The brunt of the polar vortex event last year, which is really this cold air, central cold air, the temperature pole essentially shifts into southern portions of Canada, but it allows a lot of cold air to spill down into the U.S. It was really focused in the Central Plains and down into Texas. We just had a glancing blow, but certainly had some very cold temperatures last year. It was our 27th coldest here across Ohio. Another difference we had last year that we haven't seen a lot over the last decade are very dry conditions. We had a very dry winter, which was not what we expected. Talking to Les a year ago this time, we were saying La Nina conditions. They typically mean wetter than average. We did have a La Nina, and we'll talk about what that is later. But we didn't have the wet conditions in the Ohio Valley because we never had the weather patterns in tune with some of the tropical nature of what La Nina is, which is really just cooler sea surface temperatures in the Pacific. So we were dry, 23rd driest. Much of the Northeast was dry, and much of the Midwest as well. Again, we got into spring. I always like to use these as an example. So this is the March departure from the average, very warm conditions in March up across the northern parts of Ohio here, 6 to 9 degrees above average. May was very cool, right? We had anywhere from 2 to 5 degrees below average. But in general, if you take a warm month, warm half of the season, you add a cold half of the season, and you divide by 2, you have an average season. Okay. And so across Southern Ohio, that's what we got, an average season. Now, was it average? No. It's made up of a lot of extremes and extreme variability. And that really matters in terms of impacts to our maple trees and our production as well. So I think it's just a good point to make when we're talking about averages and climate and the differences with weather. So again, here we go, asking you the question, and feel free to put it in the chat. Sorry about that, already started. How did the weather of 2020 impact the maple syrup industry last year? In reading some analysis from Les, it was not great for Ohio, but certainly could have been worse. Last year, a pretty short season, according to Les, right? Less than 30 days, about 75% of normal. Really began the last week of January. Cold February really delayed the tapping a bit. And then also, what Les noted, low sugar content, right, with all of the extreme variability and some of those issues as well, and with those very warm conditions returning in March. And so feel free to put in, those conditions impacted wherever your maple syrup production is located. But again, it's just to drive home these local conditions and how impactful they can be to your operations. All right, so let's zoom out a little bit, and let's take just a snippet here of a summer in 2017, looking at smoke in white, sea salt in blue, and dust here in the beige colors. And it's really just to kind of reiterate the fact that weather is in constant motion, right? Constantly moving. Rapid changes in temperature, precipitation, moisture, and wind speed. You'll pick up on some names of tropical systems here. Hurricane Harvey came ashore in Texas and dropped 65 inches of rainfall in 4 days in Beaumont, Port Arthur. So just keep that in mind in terms of longer term climate impacts. Western wildfires, guess what? That smoke doesn't stay there. It definitely moves across the state. And I'll show you a graph, or I didn't show you a graph, but we had big impacts in our July this past year, where our daytime highs in July were kept down and were cool across much of the Midwest because of that thick smoke in the upper levels of the atmosphere that was blocking the solar radiation. But again, everything is in constant motion. And this really helps depict our weather patterns. And these weather patterns establish the types of conditions that we can expect over time. Now with climate, it's a little bit different, right? And I always like to show this video. This is zoomed in, so it's kind of hard to see what's happening. And if you've seen previous talks, you already know, but if not, we're out walking our dog, right? So what does this have to do with weather and climate? Well, that dog is driven by some natural tendencies. It might see a fire hydrant, as my daughter likes to say, drop a little pea mail at the fire hydrant, or maybe a McDonald's wrapper or something. That dog could be moving in the opposite direction that the dog walker or you're moving, but we still expect you both to be in this general location, same location in the future. And that's based on the path that we see the dog walker taking. So even though the dog can meander back and forth quite chaotically, right, overall, the depiction of the mean path of the dog is described by the dog walker. So we like to equate the dog as our weather and the climate to the dog walker. So even though you can get chaotic motion in the weather, the high frequency changes, the mean path can be defined by the dog walker here. And I always think this is a great metaphor for, warm days in a cool season or cool days in a warm season, and how that can play out. So now global assessment. I haven't had time to update this, but this came out this morning at 11, the update for 2021. 2021 is now the seventh warmest year on record, back to 1880. The last 7 years are the top 7 warmest years on record. So since 2015, all of those years are in the top 7. The top 10 warmest years have all happened since 2005. So if you're joining the call and you were born after February of 1985, you've never experienced a cooler than average month for the planet. All right, so all the young ones out there, you've never experienced a cooler than average month for the planet. So very, very warm conditions of late. We know that, different areas have warmed differently depending on what we call decadal variation, but certainly overall, a lot of the Arctic is warming, much of the mid-latitudes, tropics, much of the lower latitudes in the southern hemisphere, a lot of our oceans are warming. So there's just a lot of warming taking place across this system. Get a lot of questions about, what causes this. So we're getting into some of the causes of the climate change first. Volcanoes, yes, they can do some changes on very short periods of time, right? Very short periods, they're short-lived. So for instance, after Mount Pinatubo in 1991, the year following that, we did have a cooling trend over the course of that following year, but those particles fall out and they don't have a long-term impact. Natural variations, you hear about this a lot with climate and how climates change. Of course, Ohio and much of the northern tier of the United States hasn't always been green. We've been covered in ice before. We've been much warmer than before. We've been covered by ocean before, so there's a lot of different natural variations at play. In the atmosphere, in the space, Earth is doing some amazing gymnastics. Sometimes we go around the sun more like a circle, sometimes more like an oval. That can change the amount of radiation that reaches the Earth during our different seasons. We have what's called axial precession. So we wobble on these 26,000 year cycles. That just means that when our equinox occurs and our solstices are at different times, right? So they march forward. And then we also change our tilt. So we're tilted on an axis, but we don't stay there. It's not static. If we have less tilt, that means we have cooler summers. Cooler summers mean snow that falls in high latitudes sticks around and we build an ice sheet. So we've been covered by ice sheets. The land that we call Ohio and even the United States has once located well south of the equator, back 460 to 300 million years ago. We eventually became a shallow tropical sea, stored all of that plant life, which became carbon, coal, which we've since burned and released that fossilized sunlight back into the atmosphere. And so all of these natural cycles, of course, are at play in our climate. But we're concerned about our composition of our atmosphere in terms of the amount of carbon. Again, taking all of that stored carbon, releasing it back into the atmosphere. We've known since the 17 and 1800s the effect on our atmosphere. We drill into ice cores and we can pull out the air bubbles, and we can understand what our gas makeup was at different periods of history. During our coolest periods, when there was ice over Ohio, we were about 180 parts per million. During the warmest periods, a little bit warmer than today, we were about 280 parts per million. CO2, carbon dioxide. Now, when we started measuring this in 1958, Charles Keeling, we were at 310 parts per million. And last May, we hit 419.2. So we've gone up over 100 parts per million in 60 years, which those natural cycles I talked about take thousands of years. All right, so that's the issue, just releasing a ton of energy back into the atmosphere, which can then lead to these changes that we're seeing. The reason they lead to the changes is because we have these awesome greenhouse gases. We have water vapor, carbon dioxide, methane, nitrous oxide, those last two in very small amounts, that keep life habitable on Earth, 60 degrees warmer with those particles. They don't care about the sunlight, but they love all of the energy coming off the Earth's surface. We increase those greenhouse gases. The only thing that can happen is the solar radiation, which doesn't change very much, has no impact on greenhouse gases. But the long wave energy coming off Earth's surface gets absorbed by those gases, stores more heat in the atmosphere, less escapes to space, and the temperatures rise, right? And it's pretty straightforward, but it has a lot of complex cascading impacts. And one of them that's important for much of the Midwest and Eastern United States is the water cycle, because warmer temperatures drive more evaporation from our soil. More evaporation means more water vapor elevated and lifted into the atmosphere. When fronts come along, they wring that water out, so we get more rainfall over shorter periods of time because we have more water vapor in the atmosphere. Overall, it's about a 6 to 7% increase for every 2 degrees Fahrenheit we increase. We have an equation that can tell us how much more extreme our precip will be given a rise in temperature. So it's a pretty robust relationship between our temperatures and our water cycle. Now, with maple syrup production, obviously, when we're thinking about the wintertime, the other thing I want to bring up from a more of a global symptom or a global impact is the loss of Arctic sea ice, because we know what happens in the Arctic doesn't stay in the Arctic, okay? And what we've seen is an overall decrease in the amount of sea ice. So this is the September sea ice, Arctic sea ice extent, okay? And you can see, since we've been measuring it with our satellites, and even we've got proxy and ship records going back a lot longer than this, but we've seen a precipitous decline, a 13% per decade decline in the amount of sea ice extent that's left over after the summer melt season, okay? What that does is it opens up a lot of darker ocean water, which absorbs more of the solar radiation. It's not reflected by the sea ice, and that sets in motion some exchanges with our weather patterns, with our jet streams in the upper levels of the atmosphere. And it often creates a scenario, and it's been attributed to creating more of a wavy jet stream. More wavy jet stream in the wintertime means we have more highly variable weather with the ability for cold air, really cold air in these polar vortex events to really plunge down into the United States, but also warmer air into the Arctic at times. So back in December, when we were warm, Kodiak, Alaska recorded 67-degree temperature late December. That beat their daily record by 22 degrees. Previously, it was 45 degrees Fahrenheit. Tremendous extremes that we're talking about. So the ocean and the Arctic sea ice play a big role in what we're seeing here across the Midwest as well. The cascading impacts I talked about, billion-dollar weather and climate-related disasters, right? We had 20 this year, 22 the year before. A tremendous amount of more, insurance and reinsurance going into these billion-dollar disasters. It matters where you live. Out west, water-restricted area, wildfires are the key, right, to that damage. Southeastern and eastern United States, landfalling hurricanes, which are becoming more intense and hold more water. So you have more, stronger storms. Cat 4s and Cat 5s are increasing. Across the Midwest and the Northeast, it's severe weather and flooding. We're a water-rich area. Even in the middle of drought, we're so water-rich, we don't know it, right? So most of our climate and most of the change can really be seen and amplified through the rain side of things, the wet and the water. So $200 million here in Ohio just spent on our rain-related disasters, okay? So if we look at the overall changes, according to the last National Climate Assessment, this is the annual change, and it's basically just taking the current period and comparing it to the early 20th century. Much of the United States has warmed. I say much, most. There are a few areas across the Southeast that have actually cooled a bit. And if you look at winter versus summer, very big differences. So in a lot of the region where I think most of you are, but certainly Eastern United States and the Midwest, warmer winters and springs. But in summertime, there's some mixed signals across much of the Midwest and the Southeast, and even in parts of Ohio as well. And we'll break those down, those seasonal changes down just a little bit. Looking at precip, it's the same. Depends on the season. Generally, the West is getting drier. Generally, the Midwest and the Northeast are getting wetter. Okay, so we've increased in Ohio, for instance, about 10 to 15%, especially in fall, but also strongly driven by our intense precipitation events, which I also want to cover here today. So I mentioned the normal periods, right? The National Weather Service used these 30-year normal periods as a way, under the assumption, by the way, that the climate remains static. This was back in the 1930s. But what we can do is we can compare what happens when we update these normals. So what we've done is we've essentially taken off the 1980s decade and we've added the 2010s. And then we can look at the differences across the country by doing that. This is the change in annual mean temperature across the country, right? So dropping the 80s and adding the 2010s, you can see that we've added anywhere from a half to as much as 1.5 degrees in some parts of the Southwest in terms of what our annual mean temperature should be. On the right, you can see the annual temperature, January through December, Ohio average temperature, and I can do this for many other states, and it would be similar, slightly different depending on where you are. But we can see much warmer in recent periods, a strong trend since the 1970s, which for much of the United States, the 60s and 70s were rather cool decade. But since the 70s, we've been warming quite rapidly here. So you can see the strong trend. Again, there is some variability year to year. There's still some of that dog nature to our weather year to year, right? But overall, we see even our lowest extremes are still above that 20th century mean, for instance. Let's break that down into season because it matters for us in the maple production. If we look at January, certainly getting warmer, right? So winters are getting warmer across much of the Eastern United States. Farther west, Iowa, Dakotas, Minnesota, actually a little bit cooler by adding the 2010s during the January month. April, the same. You see big differences between the upper Midwest and then portions of the Ohio Valley and the Mid-Atlantic where we generally have warmed during our spring, but less so across northern Ohio than during the winter. You get into July, again, it's kind of a mixed bag, right? We know that our daytime highs haven't cooled. During the summer, it's mostly the overnight lows, and it's due to more water vapor being in the atmosphere and the inability to cool off, right? That water vapor just escapes to space. And then the fall is very warm, except for these northern tier of states. So we can see differences even across the Midwest, where cooler conditions across the Midwest here, just by adding the 2010s and taking off the 1980s, a particularly warm decade for the upper Midwest. But here across the Ohio Valley, eastern US, southeastern US, it's mostly warmer conditions. I want to do the same thing with precip, okay? And I know it's late to give you all of these statistics, but we'll focus on the broad takeaways here. Again, it's getting wetter here across the eastern United States and getting drier across the Southwest. The same thing with the precip. You know, you see these strong upward trends since the 1960s with a lot of record high precipitation values for Ohio. A lot of us now, for instance, here in Columbus, our previous normal annual rainfall was just over 38 inches. It's been updated to just over 42, right? So it was a 2.5 inch increase in our normals here. Very similar conditions across much of the Midwest and Mid-Atlantic. Precip seasonally, wetter winter. How about that? For much of us here on the call. We get into April, wetter springs. We get into summer, not so much. Again, very mixed signals. We actually across here, parts of Ohio, Indiana, Illinois, back into Iowa, we've actually seen a trend downward in our July rainfall, right? So we get these seasonal water shortages that could potentially stress our trees, among the other crops as well during the height of that season. And then mostly in the fall, parts of the Appalachians, Northeast, much of the Midwest, it is, again, back to the wetter conditions. And so seasonality really matters here. I added these, and you'll have access to the slides and just some more national climate assessment stuff if you're interested. In terms of, we always talk about these 20-year and 100-year rainfall return levels. The recent study across the Northeast, what was a 1 in 100-year return value, a 1 in 100-year event back in the mid-20th century, is now about a 1 in 37-year event. So we've seen big changes in those return levels, big changes in those heaviest rainfall events. But again, I want to kind of zoom down on what does it look like for a place like Chardon, Ohio? Okay, so what you're looking at here is by every 5 years, what is the number of events, daily events, where you get between 1 and 2 inches, 2 and 3 inches in the light green, and the lightest color is above 3-inch rainfall events. So we can see this trend upward in these heaviest rainfall events of more than 1 inch, right? So most of that rainfall is occurring in these heavier events. Another way to look at it is the percentage of all of the rainfall events for the year that are greater than 1 inch. Again, strong upward trends here in Chardon. We go from about 25% of the year back in 1948 to about 35% of the time now. Much of the precip is falling in these 1-inch events or greater, okay? So clear trends from our records. And if, for instance, we take a place like Ohio and we say, what are the top 10 wettest and warmest years? 9 of the top 10 warmest years and 8 of the top 10 wettest years have all occurred since 1990. And I could replicate this for states across all of the Eastern United States and much of the Midwestern as well, right? We're getting warmer, we're getting wetter, but the details really matter. The winter details matter, and we'll talk about that as well. We still see droughts. This is the Ohio drought. I should have shown the larger picture, I apologize. But drought in Ohio, even as late as last April, right? Across much of the northern tier of Ohio, drought conditions, even though it was generally the wettest, 29th wettest year on record, parts of the state were under drought. Very wet conditions ended up the season here in Northwest Ohio. So again, we're driving changes in our water cycle that are very important. But we have to make some interesting decisions about the future and what we do. And I certainly respect the long game. That is when we think about forestry and we think about trees and species that we plant today and what it will look like in 30 and 40 years. It's a very challenging obstacle here. But, when we use imperfect tools, we use climate models. All models are wrong. Some are useful. When we look at the most useful and make the most useful inferences based on our scientific data, we're expecting mid-century change across much of the Midwest of 3 to 5 degrees Fahrenheit warmer than contemporary climate. And by late century, upwards of 8 degrees Fahrenheit across much of the northern tier of the United States. Now, forecasting weather is difficult. Forecasting human behavior is nearly impossible, as you know. And all of this is going to be really dependent upon the decisions that we make in terms of those emissions, carbon emissions, greenhouse gas emissions that we have, and can we limit those emissions to avoid even worse outcomes? The 8 degree Fahrenheit warmer Ohio is a scary outcome for my daughters, their children, for instance. Precipitation, again, winter, spring increases in rainfall, more rainfall. Again, if we're seeing heavier rainfall events and they're happening in the off season, traditional off season for ag, but certainly during the winter time, which is not off season for you folks, then we're getting heavier rainfall events in months like January and February, right? And what impact does that have in addition to decreasing snowpack? And then we get into the summer where we're likely to see drier summers. And what will these seasonal water shortages mean for our trees? Looking at 90-degree days, a more, 20 to 40 days, some parts even 60 days, 60 more days of reaching at least 90 degrees during the summertime. What impact will that have on our tree health? temperatures that fall below freezing. You know, we're going to decrease those by about 20 to 30, maybe 40 fewer nights where we fall below freezing. That's tough, right? From a maple syrup production where you need that cold to establish these trees, get them set, and then eventually get the sap flowing. And so this is a kind of, you know, somewhat scary proposition here. A lot of folks will say, okay, sign me up for the warmer conditions, but then we think about pests and disease and root health and frost depths, you know, and a lot of different things, lack of snowpack that can come into play. And also, you know, growing season, which is a little bit more for our row crops, and a lot more of our information, our precipitation falling as heavier rainfall events. So again, if you've seen me talk, you've seen this graph. I always like to refer to this graph because if you take all the current trends that we're seeing here in Ohio, we're really migrating our climate in a couple different directions toward a mid-Atlantic winter, less snowpack. Still have cool bouts, but not as much snow typically. And then we're heading toward an Arkansas summer. And I think a graphic like this has, you know, a good summary impact for all of us to think about what does maple syrup production look like, right? How much maple syrup production is there in Arkansas? What will it look like in Ohio? I'm not saying there's none. I'm just saying we have to think about these questions because our climate is definitely on the move. And so what will that look like, for instance? A lot of different things to weigh out. This is more on the ag side of things, so I'm going to skip it. But I want to get into some of these specifics into maple syrup. First, obviously, with increasing temperatures, we shift our growing zone. So we know that our species are at least at threat for shifting in terms of their growing zones. That could open up some more opportunities across the Great Lakes and other portions of southern Canada, for instance, when it comes to our maples out there. But certainly we're seeing a big shift north and west. So with that in mind, it's time to think about what are those potential climate change impacts, right? We got about 20 minutes or so left before we start answering questions. So there are some, I think, great resources and some that have even become available since the last time I talked about maple syrup production. But, you know, thinking about what are the potential climate change impacts. And this is where I'm really challenging everyone on the call to think about your operation and think about things maybe that you've already considered, information that you've come across, but also, you know, what management strategies we might have to adopt given these overall changes. So there's a great resource by Kristen Giesting, who's with the USDA Forest Service Climate Change Resource Center and a liaison with the NRCS, who put together a really nice website on some key climate threats to maple syrup production. And thinking about what I've talked about in terms of temperatures and shifts in growing zones, lack of snowpack, I think it nicely puts together a lot of that information. If we think about some of the key climate threats, availability of our trees to tap, what's the suitable habitat look like for things like sugar maples? Of course, we've got other varieties that we can fall back on that may be more acclimated or we know that trees can acclimate given a long enough period of time. But the best projections, we're likely to decline much of the U.S. range of sugar maples by 2100 in a 4 to 8 degree Fahrenheit warmer world, especially across the southern and southwestern part of its range, right? Again, but the large range could mean some acclimation, some expansion possible into parts of the Great Lakes and southern Canada, in parts of northern Maine as well. Best estimates that and I'll show research from one paper, but in general the research consensus is that sap flow, the maximum sap flow, is likely to move north by about 400 kilometers by 2100, right? So certainly shifting that main zone, the max sap flow, for instance. Tree health, mentioning the lack of snowpack, bad year for snowpack here, obviously, in general, but, You can think about, during winter when we still have cold snaps, it can cause some root dieback and some reduced shoot growth. Your lack of snowfall, but extreme cold temperatures can mean deeper frost depths, and that can impact growth and above ground growth. More frequent spring frosts, right, can negatively impact trees that respond to warmer temperatures. And by that mean, these fall springs where we get into February and March, we see 70s, even 80 degrees, things shut down. We get bud break early. And then along comes these highly extreme variable weather in March and April. And we can get these, or even normal seasonal freezes in April, right? We're not without freezes in April that can cause some impacts to our tree health. Tapping season, maybe starting earlier, shorter duration, becoming more variable. When to tap, I've heard rumblings of some tapping that's already taking place, or at least experimenting. But these things may become more often than not. Maybe we're tapping in places that were traditionally February, happening more in January. You tell me, right? These are, kind of the summary and the review from some of the literature. What about sap quality, right? It's not just winter, but warmer summer temperatures, right? And there's research to suggest that this could reduce sugar content through a process of where because it's warmer, you're impacting the respiration rates to photosynthesis and carbon storage, and that can impact the overall sugar content as well. Mineral profiles and different chemicals of the sugar maple. So great information on this site. There's a lot of additional reading material. Again, because I think there's a way to make sure that you have a copy of these slides. There's a lot of information for those that like to take a deeper dive into, maple syrup and climate production here. Additional resources per that USDA, U.S. Forest Service. There was a paper that came out in 2019. I thought it had a pretty cool title, Finding the Sweet Spot, right? Shifting Optimal Climate for Maple Syrup Production in North America. So they were really looking at a couple things that we've already mentioned previously: sugar content and sap flow, stands, different latitudinal ranges, different collection of sap volume and sugar content. So kind of looking at key characteristics that I think many of you are interested in. At different sites across the eastern United States. So a couple sites in New England here, southern Canada, up here in Northwest Indiana, Southwest Kentucky region, West Virginia region, okay, and different color codings here. So using those projections for future climate, looking at the midpoint for these historical sites based on 1950 to 2016, okay, so you can see that the tapping season midpoint day of the year, right? This is about mid-April in these far northern regions. It's late February here in the far southern regions. But then you can see a decline in all of these regions toward much earlier conditions. So up here in southern Canada, midpoint tapping season would go from mid-April to more like early April to even late March, right? In terms of when that, so more like New Hampshire. New Hampshire, more like Massachusetts or even farther south. And then, places across the southern reaches getting much, much earlier in the season. We're talking late January, mid to late January as kind of the midpoint. Okay, so very strong evidence of those changing seasons or even shortening seasons as well. If you want to dig into more, they looked at different sugar maple changes in range, sap, and sugar. So again, that midpoint collection is here, but total sap, sugar, and total syrup, and then those changes. So you see a lot of the browns across the southern reaches means declines in total amount of sap volume and sap sugar content and total sap as well. So that optimal production is really projected to shift northward pretty strongly by the end of the century. Okay, so that brings up questions about the viability, but I don't know if I mentioned it previously, thinking about other ways to combat this from a management perspective, which we'll get to in just a second. I did some back of the envelope calculations based on that paper, looking at a few states here honing in on Ohio, of course, but looking at what was the mean March temperature, for instance, across Ohio, about and then looking at the change over that period of time. So we've warmed about 2.1 degrees Celsius. That rate that they found of 4.3 days, it's about a 9-day earlier calculation there. Looking at the sugar content, and again, doing some of those back of the envelope calculations, really a decrease in that sugar content as well, just as an example, and certainly something that I think is important for all of you to think about and discuss as we start to open up questions here in a few minutes. So what do we do about this? Okay, that's the big question. What do we do and how do we respond? If anything, some of the big takeaways I'd like you to take away from the climate aspect is we know that it's changing, right? We can see that it's changing. We're feeling this changes, and we're currently experiencing the effects. So I'm really honing in on this idea of adaptation and mitigation, and how do we make decisions that are going to improve our outcomes within the maple syrup industry. There's some good resources out there thinking about some of the maple production strategies. And again, as I talked about earlier, the weather and the climate are very personal. They're very localized. And so how we address it is going to differ greatly based on geography, elevation, even what your stands look like, the species. All of these things are going to come into play. And it's very important to remember adaptation is really a local process. But some of the strategies that are suggested include diversifying the species, which including other things like red maple and birch and other things as well. Heavier dependence on technology, vacuum tubing, processing technology increases as well. Cleaner sap, for instance, increasing taps. Maybe that becomes a strategy. Again, none of these, I'm not judging any of these. These have just been put forth as strategies to overcome what we're doing. Somebody already put in the chat, shorter seasons, you might have to adjust when your season begins and when it ends. So taking advantage and knowing these shifts in the seasons could help you take advantage of sap flow as well. Monitoring, I think heavy monitoring would go a long way into understanding like in-season decisions, which a lot of you do. There's this idea of late season buddy syrup that I found interesting as well. Using syrup as a sweetening agent, but finding additional markets, right? Or creating additional markets, or somehow stirring those markets so that you could still utilize sap that you're getting as well. And again, about limiting other environmental stressors. We've decreased a lot of the acid. It's not minimal, it's not gone, obviously, but when we think about Ohio and points eastward, a lot of acid rain and minimizing, but thinking about pests and as we start to encounter some pests that maybe are more prevalent in the South currently than they are here, that might take a toll as well. So how do we prevent some of that from happening? So, I think in all you'll see that, yeah, it's a challenge to think about maple syrup production under these conditions. But if we're not taking any action, then ultimately I think the industry suffers a bit, especially across this region. So it's good to have the management ideas in place and to think about as a community how to respond to these changes. And a lot of you are already doing that. Okay. So now, what about right now? What's happening right now? So I want to end today's presentation on kind of the seasonal outlook across this part of the world and where we're heading over the next several months. I thought I had included a look back at December, but I'll just mention it in a second. So I already talked about La Nina a little bit. So La Nina is really just cooler sea surface temperatures in this part of the tropical Pacific. So here's South America. Here's North America. This is the Pacific Ocean. Here's the equator. And the blue colors that you see here are how the sea surface temperatures compared to average yesterday. Okay. So all of this blue color means they're cooler than average. And that means we have a La Nina condition. And it's not a system. It's not a storm or a hurricane. Earlier presentation, I talked about its brother El Nino when it's warmer than average. Isn't Chris Farley, I am El Nino, if you remember that skit from SNL many years ago. La Nina is just cooler than average sea surface temperatures, but it impacts our weather patterns. And here in the Ohio Valley and much of the Northeast, it tends to be a wetter condition, and it tends to have the biggest impact during our winter time, okay? So, sorry, I keep jumping back and forth. So when we look back at, there we go. Sorry for the dizzying effect there. La Nina is in place, and it's likely to continue through winter. What that means is it really amplifies our jet stream. So looking at the figure down here on the bottom right, we have this polar jet stream that can really extend well up into the Arctic. Cold conditions across the northern tier of the United States. It tends to be a little bit warmer across the southeast and southern reaches. And here in the middle, across the Ohio Valley, it's almost always wet. We get frequent systems coming through, and the combination sometimes of the cold can give us some big snowstorms, but that really hasn't happened this year because we haven't been phased between the moisture and the cool air. But we certainly have this highly amplified pattern in place. December temperatures were really across much of, I know in Ohio, it was our second warmest December on record. Cincinnati hit 69 degrees, which is the warmest on record for Christmas Day back to 1871. Top 10 in all of our big cities, Toledo, Cleveland, Columbus, Cincinnati, and Dayton. Soil temperatures on January 2nd were running anywhere from the upper 30s to low 40s across northern Ohio to 52 across southern Ohio on January 2nd, soil temperatures at 4-inch depth. So very warm conditions, largely driven by this pattern that we saw with La Nina and a combination of what's happening in the Arctic. And generally during La Nina conditions, we are warmer than average here across much of eastern United States, okay? It can lead to slightly snowier conditions across much of the Midwest. It's not been the case this year. In the bottom right, a little bit snowier here in Ohio region, less snow in the mid-Atlantic, and snowier across the northern tier, but certainly wetter conditions for much of the region during our winter time. So that's typically what we see in La Nina, but it takes more than just one pattern. And the other pattern that we pay attention to is what's happening in the Arctic, right? Again, back to these polar vortex events, we always have a polar vortex. When it's stable, the cold air remains across the polar region. We have a strong polar jet stream, but when it becomes amplified, which it can do a lot more often under La Nina patterns, we get a wavy polar vortex. We get some warm air pushing into the Arctic, and colder air can spill down into the United States. And so we can get these brief, really cool periods. So what does it look like right now? Well, much of December, you can see the Arctic oscillation. That jet stream was very strong during December, and it really kept all the cold air away. So much of December was warm. We finally started getting to some cooler periods by late December, really late December, really the 1st of January. Again, there's a lag in this response. Now we've got a little bit of moderation, and it's pretty neutral here in terms of the forecast. But what I want to pay attention to is some signals that are coming in now for us looking at the weather forecast. This is January 25th. So typically, much of us experience our coldest week between January 20th and 25th. This lob, this is just looking at the jet stream, okay? Upper level winds, high in the atmosphere. We see this circular figure or feature here, which is really indicating kind of displacement of that polar vortex, right? A weakening of the jet stream, of displacement of that polar vortex, which is going to allow more cold air to slip down into the eastern United States, really cold air. And as a matter of fact, this is the January 25th near surface temperature compared to average, right? Compared to what it should be. So much of the Midwest, we're looking at 15 to 20 degrees below average. Again, during the week that's already the coldest week of the year, and across much of the Northeast. So those that are really wanting a reset, I do think it's in the offing here. When you look at our 8 to 14 day outlook, again, that week of January 20th through the 26th, much of the Eastern United States, this is a big pattern change for what we've seen through much of the winter so far. Really likely to be below average temperatures, and again, happening during that coldest week of the year. And also a pattern reversal in terms of precip as well. So after this week, we've got this storm coming in this week that's likely to dump, I should say, probable to dump at least shovelable snow in eastern Ohio, but much of the mid-Atlantic and down into the south once again. I'm not bitter or anything about the snowfall. But anyway, then we turn a bit drier, right? So cold and dry for that week of 20th through the 26th. So I think that that's really, you can tell me what impact that'll have on the trees. Now, looking again, even into the first week of February, overall, it does look like the northern tier of states will lean or likely be below average temperature-wise, and not very La Nina-like, but shifting again toward a more drier than average pattern, at least temporarily for this 3 to 4 week pattern. Okay, I do expect, again, as we head into more of the seasonal overall winter outlook, La Nina conditions and impacts across this portion where you see the above average precip really takes full form in February and lingers into March. We have a 67% chance of La Nina continuing through the upcoming spring. So I expect highly variable weather will continue with a few of these cold snaps. Overall, wetter and warmer than average, okay? Again, if we get snowpack, we can protect those frost depths a little bit. If we don't get the snowpack with those extreme cold temperatures, that could have an impact, but we're likely to still be above average warmth. So what does the season look like? How long is the season? I think it's a little bit up in the air, just depending how variable we get. The potential is there, right, to spring back toward warmer conditions after this cool snap here late January, early February. And then as we head throughout the spring, I do think it's going to be above average overall. So again, likely to come to an end here sometime in March. And overall, the colder conditions could lead to slower warm up of our temperatures, but again, not too big of an impact here with this crowd. So kind of the summary, overall summary, and then open up for questions. Climate change is real and it's personal, right? So it's going to impact you very differently than your neighbors within your state, and your neighbors across the borders. Conditions are warming, especially winter, and especially at night, and becoming more variable, highly variable conditions. Precipitation is increasing, especially fall through spring, becoming more intense, and we're seeing more intense rainfall even in the colder months, January and February. Overall, on the maple production, climate change impacts are likely to impact tree range, tree health, and volume of sap and sugar content. So we should be thinking about these things when we think about how do we adapt, right? And that's really a question I turn around and pose to you appropriately in the month of January, right? Janu's facing forward and backwards, but how do we adapt? And what does the future hold for maple syrup production in some of the southern regions and even the northern regions currently? La Nina conditions are likely to continue. Warmer overall. We're going to have these highly variable weather with cold snaps, but generally wetter than average throughout the rest of the season. So with that, I found this nice picture on public domain picture on Flickr. Maybe you're on here, Keith. I don't know, but was taken in 2010 down in Claremont County. I just want to thank you all for sticking around this evening and hope you all have a great season. I'm certainly looking forward to tasting what comes out of Ohio this year for sure. So thank you so much.
Thank you, Aaron. Great presentation. Lots of data to think about.
Sure.
And the forester in me, looks at that broader picture of what you were talking about is, what does this do to the trees? We have a lot of landowners that ask about the species changes, yeah. What to lean towards. So, there's a lot of questions, and we make our best judgments with information like this. But if you are a person who depends on their woods for maple or timber or whatever it may be, you got to be in it for the long haul and understand what climate's going to do to that woods, because it's going to have an impact.
And you bring up a good point too, and I make this often, and I didn't yet today. We talk about climate change as a threat multiplier. You have a lot of challenges on your plate already, right? Mm-hmm. And climate comes, climate is kind of that creeping disaster. We often think about it, although some of the changes are very fast. And no matter if I'm talking to water resource managers, timber resource managers, it is, after all, we call ourselves land stewards and resource management stewards, and it really challenges us to think about how do we manage our resources in a better way to be better equipped to handle these multiple threats.
Yeah. And sometimes landowners get frustrated and they'll just kind of throw up their arms and, why do I bother anymore? This is just getting, you add the invasive species and some of that other stuff in. And we've got landowners, I think, that are struggling with that thought process and, how to do this thing that they love with all of these pressures that are impacting. So thank you for an awesome presentation. We've only got, let's see, a couple of questions here. So let's look at, Lori Nichols asks, is there a predicted number of years that we have left for maple syrup production before it's not viable? So look at your crystal ball, Aaron. And
yeah, so I in all contexts, again, I don't like the, I often try to avoid these tipping point questions because it's going to vary, right? I think, again, it's a personal decision based on the landowner when those obstacles might become just too much. I don't think that, again, it's not something where it's a complete collapse in 2027 and it's never going to happen again. It's going to be one of these things where you start having, where is the point where you start having, where it's not economically viable more often than not, right? And so it's hard for me to pick that year, not being one that taps trees, not being one that processes the sap, and so, but I do think that it's not far off to think, if you look at these, it's 2022, right? We can already say that Northeast Ohio, for instance, has a Southern Indiana climate of 2003. So in 20 years, we've already shifted that way. Wow. So it's here, it's now. And I think I don't want to be one that kind of says, you probably should give it up in a certain year. But I would say, as we, depending again on what we do to avoid even the worst outcomes, we're baked in. This is my scientific best guess. We're baked into a 2 to 3 degree Celsius warmer world, which means 4 to 5, 4 to 6 degree by the end of the century. That's where our climate sensitivity that's where our models right now kind of come into play. And so I would say that it's unavoidable that we're going to warm, 3 to 6 degrees Fahrenheit across much of the eastern United States by mid-century on average. And so 20, 30 years, right? 20, 30 years. If you had to hold me down, 20, 30 years become even more of a challenge here in Ohio.
Yeah.
But again, what markets open up? What other opportunities open up? What are some of the, can we turn this around? Do we end up getting a lot of carbon sequestration? Do we get large changes in our industry where we emit a lot less? The scary, I use this because in kind of a carbon sequestration rounds, because carbon sequestration is important and farmers, for instance, want to know how much they can sequester. The latest statistic I saw was if we all switch to renewable energy and we all live to 70 years old, we would collectively remove 1 second of our current emission rate. Okay.
Wow.
What does that mean? That means that unless at the higher level, the industry, the transportation, the energy sector, we're not making massive transformational change. I'm not minimizing individual effort, right? But the scales are vastly different. And so we have to have individual action, but then other things of what can we do to make larger changes as well, because we can't just rely on carbon sequestration and things like that as well. So just for perspective, so it all comes into play.
I might interject something here too. You know, the focus of tonight's, by the way, Aaron, you are a gifted communicator.
Thank you.
Very seldom am I excited about a 7 p.m. webinar. You are a great speaker, always learn a ton, and tonight was no different. One thing we didn't mention is the focus is really sugar maple. And I bumped into the chat box a resource for folks who want to take a bit of a deeper dig here. This is a link to the U.S. Forest Service Tree Atlas. And the specific page highlighted here is the sugar maple. And while sugar maple is not an A+ climate change adapter, it's also not a solid F. Right. It's not terrible. What we do know, though, is that the blue ribbon winner of climate change adaptability also makes pretty darn good maple syrup. Yeah. The winner, chicken dinner, is red maple.
Red maple. Yep.
So if you've been around the Ohio State maple team much, you know that we're focusing more and more on these alternative syrup making species. And even if it's something like an Aaron Wilson webinar to scare you away from solely paying attention to sugar maples, what that might tell you is that to be economically viable 20 or 30 years down the road, maybe it's time to start thinking about that reverse osmosis unit, right? Which takes that not quite as sweet sap and makes it sweet sap by the time it hits the evaporator. So again, there are a lot of ways to approach this problem that does not appear to go away. And I don't think that Aaron has hoodwinked us tonight into thinking that it will magically disappear. But there are different ways that we can cope with this and adapt. So I'd encourage you to check that out. And from that link, you can click around to some of the other tree species to see how some of those sort of forecast or respond to climate change into the future.
Yeah, that's a great resource, the Climate Atlas. And you're right. I should have mentioned more about the red maple. I mentioned it in there, but that is exactly the type of thinking and strategies that we need to have, right? Is finding those niches and finding those things where we can adapt and overcome. And you know, you say I learn so much every time I engage this community, and things to follow up on. So hopefully, you know, I can come back in the future too and kind of give an update, maybe a better forecast. But anyway, I digress.
I would like to highlight one of your slides. You mentioned the thing about quality of sap, warming up, and the things that we have to do. And I think this is an area where we're really going to have to tighten our belts a little bit as we go forward. We're going to have to see how we can do a better job of making our sap a better quality, maintaining the quality of the sap before we boil it. If we're going to have warmer climate, we've got to be able to combat the bacterial growth of that sap. And so this is going to be an area where we're going to have to pay particular attention. And I agree with Gabe. The red maple may be the star before this whole thing. It may be the saving grace as we go down through. So it's how we do it and what we do it with is going to be very important.
And Aaron, I will add that if you want to get experience at tapping, Gabe and I invite you to the OSU Mansfield campus, and we'll put a drill with a bit in your hand and turn you loose in the woods.
Give me a day and I'll be up there.
Okay, anytime. So let's see here. We've got Peter asks, are the climate changes to blame for the low sugar content in the trees over the past couple of seasons?
So I guess the question would be where, right? So
yeah.
Peter is, I don't know where Peter is located.
I don't know where he was from.
I mean,
Peter Gregg.
But summer temperatures have a lot to play, right? The summer temperatures have a lot to play. on the sugar content as well. Maybe I'm just asking you, one of the things about summer is daytime highs aren't warming as much, but the overnight lows are a lot warmer. So I'm wondering if that consistently overnight lows might be having an impact. Maybe I would turn that back to you folks. Yeah.
Okay. Well, I think that there's a lot of things that can impact that. Some of it can be genetics, but some of it can be site, soil. I mean, there's a lot of things that play into that we don't probably have as good a handle on as we should, I think.
Yeah, I mean, the focus of this is climate, and climate plays a role, but it's not the only variable, right?
Right.
Like
Tim Perkins did a pretty good study on that out of Proctor. I can't quote it verbatim, but I do know that the impact, sugar is impacted by the way the fall develops, just before leaves fall. He did an excellent job. And I think if you go back into his research there, that you will find that that has an impact. Also, the warming of the sap has a big impact on sugar content. We've dramatically seen drops in the amount of sugar we're gaining towards the end of the season. And at the beginning of the day, we see a higher sugar content. And by the end of the day, it drops off. And the reason for that is primarily because the bacteria are really munching on the sugar. You got to remember, it's only 2% sugar. It's 88% or 98% water. So it doesn't take long to take the sugar out of sap under high bacterial conditions.
So Eddie Lou asks, is anyone in Ohio fall tapping? And do we think that will increase in the future? And that's not a question for me. Les, is there anybody?
Yeah, they've tried it. And, we've gone and, taken a look at it. And I have been on Facebook and on social media and really taken a few people to task for doing it, because really it's not the solution. Just think about the person that tapped, and then all of a sudden we don't get cold weather until the first part of February. And those trees are sitting idle for probably 3 to 4 weeks. What have you gained? And of course, they're going to talk about double tapping, and we don't want to even go there. That's not part of this seminar, but Abby Vandenberg is pretty well established that this is not what you want to do. So I haven't seen it. There's been a few of the guys that did it, and some maybe were successful, some weren't. So.
Okay. Mary Lou Tebby, this is kind of a question I get a lot on the whole climate change. Would it be good to plant zone 4 trees for extreme conditions? And I get that. Steve Matthews and I have talked about trying to create a list of trees, to think about moving up into different zones, coming up maybe a zone or 2 from the south, and starting to look at planting those different species. But I get that question a lot. Should I start looking maybe a zone south to pull trees up to plant for the future?
Yeah, so that's definitely, I was on a webinar earlier today with the USDA, and David Peterson up in the Northwest. But one of the strategies is to really look at nurseries outside the zone and start expanding seed and sapling, and to start to think about, and this is where I would say sometimes I get into these philosophical questions, or philosophical, not debates, conversations with, if we're locked into the climate changing, then why are we so steadfast in keeping all of the plant life exactly the same? Right. If it's not going to be thriving here in this environment. So a lot of times you'll hear things like climate plus species, or starting to introduce and diversify your maybe forest stands by introducing some species that might be able to live here a little bit better. So I think there's something to that. It's certainly from an adaptation standpoint. You're obviously up in Northern Ohio are going to get our Central Ohio Buckeyes eventually, and then eventually Michigan will have them all. So that always ruffles some feathers when I talk. Obviously,
Yes.
we're not tapping buckeyes. There's pointless poisonous nut, but I'm just kidding.
Hey.
Hey, I'm a buckeye through and through. So all right. No, they're beautiful. I mean, all the trees are beautiful, but yeah. So I think that there's something to that, you know. But like you said, I mean, Gabriel putting in the tree atlas, that is such a useful tool. They've updated it recently, and there's constant work going into that as well. So
yeah. I'll say even on Ohio State's Tree Campus Committee, we've been having that discussion about reaching for more southern species to plant in some of the new projects on main campus. So we've had those discussions, and we're kind of strategically picking some trees to
like the
plant.
Kentucky coffee tree. I see those popping up on campus.
Yep. You may see things like post oak, some other things that are more of considered a southern Ohio species that you'll start to see on campus. So, you know, we'll see.
Sweet gum.
I love sweet gums. Nobody likes the things they drop.
Yeah.
I absolutely love them. The colors in the fall are spectacular.
Oh, they're beautiful fall color. But then I usually get the questions about, so how do I stop them from producing these nasty little things that I can't walk in my yard barefoot? I'm like, sorry.
Can't have it all, right?
There are chemicals out there, but it's not pleasant. So our last question here is from Jack Evans, and he said, has there been an increase in high wind events? And if so, why is this happening? Loss of maple trees due to these events are a concern.
Yeah, it's a great question. There's a limit on events and what we can actually establish in terms of trends. Larger things like precipitation changes, droughts, hurricanes, tropical systems are a little bit easier. When you get into, you know, high wind events can really impact less than an acre, right?
Right.
So trying to, one, observe those and have observable data on those events, and then to track them over time is a little bit more difficult. So I would say the jury is out on that in terms of, are we actually seeing an increase in these high wind events? I would say that what we definitely are seeing are wetter soils in general, and wetter soils and high wind means devastate, you know, a lot more kind of trees collapse, you know, falling over and things like that. So it could be that maybe we're not seeing increased wind, but maybe more damage because of other factors as well. But we just don't have enough data and understand exactly how these small scale wind systems are changing.
Well, and in our woods and in many other woods, the perception of high winds is amplified by the fact that we're still having ash trees come down at a relatively rapid clip, right?
Oh, yeah.
Every year I'm like, oh, we finally got all the ash trees. And every year I lie to myself. But yeah, it does seem like we've had a couple pretty dang windy years in a row. Lots of those severe thunderstorm warning alerts popping up on cell phone where chances are another chainsaw job or two hit the ground. So that's a great question.
Yeah. Now, Tom DeHaas is still on here, right? So what I didn't do was he's still on there?
Let's look.
Maybe he's not. You still there, Tom? Still on.
He's
Great.
there.
This is just for you, and I've used this before, but I had to remember what it is. Since we talked a lot about weather and climate, just remember there's a basic difference between weather and climate, right? You can't weather a tree, but you can definitely climb it.
Oh, geez. Stay away from Tom DeHaas.
Tom DeHaas got one to go for tomorrow.
Yep.
That's right.
Added to his repertoire.
Yes, Tom has a way of pulling those in and throwing them at you before you know what you've been hit with.
That's right.
He's probably typing one into the chat right now.
Probably.
Yeah.
Probably one on the way right now.
I like the good presentation, bad jokes comment.
Yeah. I have 2 daughters. I have to keep dad jokes alive.
So we have one last one question that says, forgive me in advance for this. any genetic modification studies on trees? In the maple side, we are getting back into looking at our super sweets, genetic modifications there, but overall, I mean, there's always some, at least general trees, I guess I would say there's always someone looking at something, but I don't know, Aaron, if there's anything.
I don't know from a, maple production standpoint. I mean, you can look, a lot of universities with research dollars, Wake Forest, $3 million grant looking at heat tolerant tomatoes. As I said earlier, I thought tomatoes were heat tolerant, heat loving, but apparently we need to make sure they can grow even hotter. But yeah, I mean, genetics is another adaptation. They didn't include it here, but certainly on crop side. And I don't know, thinking about pest resistance, I know that even with the ash trees and some attempts to modify ash and to withstand and kind of not be susceptible to the ash borer. But yeah, I don't know specific to, for this.
I just wondered, and I, this is probably good for Kathy or Gabe, that don't trees, I mean, I would think trees, there is an adaptation to climate. We adapt corn all the time. We adapt row crops by changing the genetics and so forth. That is a natural progression that plants preservation of the species, so to speak. Maybe I'm getting over into animals now, Gabe. I'm getting over into your area. But, I don't know. Is there such a thing as a preservation of species in plants? Mm-hmm. I mean,
there trees. Are some adaptations. One of them that it's not a tree thing, but one of the things that I always refer to is kudzu. When I was in undergrad, we always talked about kudzu would not survive north of 70. I mean, that was the line that everybody kind of drew. And now we have kudzu in downtown Cleveland and Akron. And it's, as you get cold events, the plants that survive and thrive, those genetics are replicated. And so you lose the ones that didn't tolerate those cold temps. And so there are some genetic modifications in that case that probably the kudzu that's living in downtown Cleveland is not like the kudzu in Southern Ohio. There's probably, some genetic differences. But yeah, it's, nobody wants to introduce new things because we don't know what they're going to do. I mean, we've introduced wildlife species to deal with some things. We've introduced different plant species. We're dealing with spotted lanternfly now that came in on its own that could impact the maples. So there's a lot of genetic things that can be looked at, but that's a long haul research.
Oh yeah, and trees has got to be.
Trees are a long haul research project. They're not like corn and beans. A 1-year rotation, you're a 80-year rotation. Oh dear, what's Tom up to? Do I want to read that one?
Yeah, it's okay. It's safe.
Why is Santa like a ninja? He has a black belt. Oh dear, Tom.
I see Mary Travis put an interesting observation in there, and I just want to make sure I clarify a little bit. Like, I'm not advocating, by the way, of not thinking about native plants and biodiversity. It's very important as a bird watcher and an avid bird lover. I know how critical it is. And native plants are usually less resource heavy, right? And that's one way we save energy, and it's one way we save water resources. So, but I think it is worth the conversation to think about. Maybe we preserve species by a blend of techniques. I'm not the expert, but it's just something that comes up often when we think about, okay, if we're locked into a climate change, maybe it's going to take a little bit of both, right? We have to understand and know how we should adapt while knowing that native species are good for the biodiversity and good for the situation we're in. So I just think that's a really good observation. And there's no answer, right? We're really in a conversation about this.
I think most of us who deal with the invasive species side of things, that's just not, we don't want to go there, you know. And I've had conversations with other folks in extension about, oh, well, but it's thriving here. It's like, yeah, but you know, what are the other negative impacts on the invasive side? So I don't think any of us want to introduce anything that would be considered alien, but I do think we need to look at the native species that are south of us and start seeing where we make them fit.
As Gabriel mentioned, red maples aren't alien.
Yes. Yeah. Probably if you ask some foresters, Aaron, they would tell you they were not only alien, they were
trouble.
Big trouble. All right, folks, we're at 8:29. Any other questions? I didn't see anything else pop up in the Q&A. And for that,
Aaron, are you going to make that slide set available to us in any form?
Yeah, absolutely. I can put a copy digitally. I can also print out PDF and send it to you if it could be shared that way. But what's best? I mean,
somehow I've got to get an article pulled together out of this, and I'm never going to remember everything that's on those slides.
Well, of course.
So the video will be posted on the Woodland Stewards website.
Okay.
And we can, Marnie, you want to post?
Yeah, I can post the, Aaron, if you want to send me the PDF of your slides, I can post it right along with it if you're okay with that.
Yep, absolutely.
Great.
That'd be good.
All right.
And just to be clear, I think I heard you say it's going to be the best maple season ever, right?
I'm still recording, Gabe. So he's
disclaimer, that's what we all wanted to hear you say.
Somebody in the room is going to have a spectacular season.
It's true. There's always an outlier.
That's right.
Fantastic.
All right, folks.
Thank you so much, Aaron. That was awesome.
Thank you. Yeah.
Hey, you're
Thanks,
welcome.
Aaron.
Awesome.
Always a pleasure. Yep. Have a good night.
All right. Thanks.